All right, everybody, something special today just for you. Let's build the YouTube recommendation algorithm. Let's be honest about the goal. You finish a documentary on quantum physics, and the system serves you top 10 funniest goat screams. Because its primary goal isn't to educate you, it's to keep you watching, and our design needs to reflect that. If you were in a FANG interview and get asked, how would you build the YouTube recommendation algorithm? You could say collaborative filtering and content-based filtering. Then, you'd explain that collaborative filtering is a method that finds videos for you by identifying other users with similar viewing tastes. It recommends videos that those similar users have watched and enjoyed, assuming you'll probably like them too. As for content-based filtering, you'd say that it recommends videos by looking at their intrinsic properties. For example, if you watched a lot of videos about Python project, it will suggest other videos that share similar keywords, descriptions, or topics. You'd get a gold star for that answer, for that boring answer. It's like saying you build a car with metal and wheels. It completely misses the juicy, controversial, and brilliant engineering choices we're about to make. The first thing to know is we can't just use one model. We need a multi-stage architecture. And the entire design is optimized for one single metric, keeping your eyeballs glued to the screen for as long as humanly possible. Not happiness, not education, just watch time. So let's design that system. Step 1, the data pipeline. We need data, and I mean a metric ton of it, flowing through a real-time event logging pipeline. We start with the obvious explicit signals, likes, subscribes, the stuff users consciously give us. That's ML 101. But the real gold is in the implicit signals. Dwell time, completion rate, did they slow their scroll over a thumbnail but not click? Log it. That hesitation is a feature. A like is passive, but a share is an active endorsement. Did they turn up the volume, rewind a section, log it all? It's not creepy if it's for improving user experience, right? Step 2 is candidate generation. With billions of videos, we can't rank them all in real time. So we build a bouncer, a fast, efficient first-pass filter. The go-to architecture is a 2-tower model. One tower generates a user embedding, a dense vector representing their tastes, history, and that secret love for GOAT videos. The other tower generates an item embedding for every video. At request time, the retrieval step is a k-nearest neighbor search. We perform this lightning-fast search against a massive vector database, using a library like FAISS or ScaNN to find the few hundred videos closest to the user's embedding. These are our candidates. Step 3, the ranking engine. Now we bring in the heavy machinery. We take those few hundred candidates and feed them into a massive deep neural network, or DNN ranker. Here, we can afford to be computationally expensive. We'll use hundreds of features which we can categorize. There are user features like demographics, context features like time of day and device type, and powerful cross features that combine user and item attributes. But what are we optimizing for? Our objective function isn't just predicting click-through rate, we're predicting expected watch time. Which video won't just get a click, but will maximize the user's session duration. And that's the technical reason you get the GOAT video. Our DNN ranker, optimized for session watch time, learns that after a mentally taxing video, users are susceptible to a cheap dopamine hit. It's not trying to find the best content, it's making a probabilistic bet that a screaming goat has a 70% chance of leading to another click, maximizing the session. We've literally engineered a feedback loop from hell. From a technical standpoint, it's a masterclass in behavioral engineering. We've built a machine designed to exploit cognitive biases to maximize a target metric. It's not built to enrich your life, and it's working perfectly. So how would we fix it? This becomes a multi-objective optimization problem. Instead of a single-minded focus on watch time, we need to balance engagement with exploration. We'd redefine the objective function to reward the model for introducing novelty and serendipity. It's not just about finding the next best video, but a portfolio of good videos. We could even implement techniques like re-ranking for diversity in the final stage to ensure we don't just show a slate of videos on the exact same topic. We'd be optimizing for long-term user trust, not just short-term engagement. So what do you think? Would you change the objective function, or is the algorithm just giving people what they want? Let me know. And if you want to get your hands dirty with more problems like this and prep for your next FANG interview, head over to stratascratch.com. Now, if you'll excuse me, our model is predicting with 98% confidence that I want to watch some GOAT videos. Bye.
All right, that's it for me.